And welcome back to SIROWORLD 2016. I'm David Semple, joined by Executive Vice President of SICAT, Mr. Jochen Kusch, and Dr. Javier Vasquez.
Thank you.
We're talking about, you're the inventor of this thing.
Yes, we actually brought in the idea to have a virtual patient. And if you have a virtual patient, you need to have the movements of the patient in the machine. So that's why we came up with the idea of function.
That's awesome. Well, now that you have this machine, Javier, what's next in the CAD/CAM restoration?
The beauty of this is that, as Jochen say, we making a virtual patient. So now all this information can be transmitted to our CAD/CAM system. So basically, we put in a brain in the CAD/CAM system to function as the body work. We have protocols when we work chairside and laboratory side in the sequence that we make adjustments and we transform that information in a functional way. So the plan that we have and how we expect for the future is two bigger possibilities. The first one is for occlusion in habitual occlusion, let's say. So we're really popular with CEREC because we do a lot of one-day restorations, and this opens the opportunity to do full quadrant dentistry when we can be really productive and we can benefit the patients big time, based in time. So the beautiful alternative that we have now is that we record all this information for the patient, how talk, how function, how they bite, all the parameters that this happen, and we put it into the software. And we can do quadrant dentistry now. All the crowns will become pre-adjusted, so when we sit the crowns, it's not going to be no adjustments whatsoever. Before we were static. And that's fascinating.
And that's, I have to say, I'm an engineer. I'm not a medical doctor, not a dentist. So when I stand in front of a group of dentists, I always say, you know what, you guys, you are the only profession I know that's still working with carbon paper. You create a nice restoration, then you put in the carbon paper, you make clip, 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 and then you grind it down.
We destroy that beauty.
Yeah, it's so archaic, isn't it?
Yeah, why not do it like the rest of the industry? Like everywhere, go digital and bring in the movement and grind down on the digital model. And then you don't have to destroy the nice crown. So that was...
And it's not just aesthetic factors. We know that every time that we touch these crowns with these diamonds, that we create microfractures.
Right.
So unfortunately, depending how we treat the restoration, we can possibly create a failure for the future. So this guarantee that the restoration will be sealed by the temperature when we put it in the oven, that will keep the consistency of the glazing and the intensity of the surface, that is going to be more long-lasting restoration.
You don't want to go back to that because, I mean, I'm not a dentist. I don't know that business at all, but it seems so counterintuitive, so archaic that I would be chomping on a piece of carbon paper to design a mark so that you would then go erase that part of the mark, and then what if I moved my jaw to the bit and it slid that way and you're just sawing it away? So
yeah, and that's exactly the thing. So let the patient do all the movements before you create the crown. And then that's what you do in CAD/CAM anyway. You know, cars are designed like this. Like everything is designed like this. Let's do the same in the patient.
Well, let's talk about this, though. How does that information get into the software itself?
We have the alternative that we create a protocol chairside that meet clinical doctor. We have the protocol to get the information that we want. We found the more relevant information in a patient, the speech patterns, some movements that they're not as sectoring movements. It's more about what happened when your teeth are apart, you hanging, relaxing, you talking, you're chewing your food. And this is what it shows more function, because we human beings that we're in constant movement. The other alternative that we have beautiful with this information in CAD/CAM now that we do a lot of full mouth rehabilitations and planning full aesthetic cases is that we can determine how much length we can put in these restorations. Most people is focused in smiles, and unfortunately, we didn't have the tools before to see if this smile that is going to be amazing for the patient face, eventually is not functionally working for you. So all this beauty that the technician is putting in the ceramic need to be grind down. Eventually, this can create a problem for the patient health-wise, because we made the teeth too long, patient start trying to function, start banging those teeth, and we have the chance that the body can react anyway. Can be muscle-wise, the neck, can be the teeth that can be breaking. We have a body that can have weakness dependent of us. You know, each of us work in a different conditions.
And how does an engineer integrate biomechanics with, and maybe it's a silly question, but biomechanics with something so specific as
Well,
triangulation?
Well, the thing is, we're in the field of dentistry since 13 years now, and we pretty much evolved with the technology. And we are listening to our customers, which are dentists, and we see their problems. We see the chipping of crowns. We see the failures they have. We see what they want to achieve. They want to achieve the best for their patients. So what we do is we look into the whole process from the outside as non-dentists, and we think, well, what could be done differently? What could be improved? What is actually going wrong? And then we make provocative statements. And by making these statements, we get into discussions. And we didn't agree in the beginning, and we adapted. Like in the beginning, we were fighting, and then we agreed that, oh yeah, that's the right way to go. And it was fun to have this development.
Well, I could see why how an objectivity of someone who is non-linear would be a benefit to you, because he's looking at a problem with a different eye toward a solution.
Totally.
You have a specificity that you're looking at it. So I get that.
At the beginning was tough, but after that we get to a standard point, everything was so visual. I think the biggest feature that we have is we human beings that we visual. Whatever you see, you can diagnostic. Sometimes we have limitations because we cannot see. And I think that's the best description for me for SICAT. It's a company that is trying to make everything predictable. That's why we have SICAT implant, that we can make the surgical guidance, because we're pre-planning everything to success. Now, this was the missing piece, I think, that now, before we were able to do beautiful restorations, but how about that predictability? How about those adjustments? How about that comfort of the patient? Plus all the options that we have to treat the patient to increase the health and the occlusion in the patient.
I also see the economics, because you're minimizing error quite dramatically, right? So
Absolutely.
You're getting to the solution faster, easier, quicker, better.
Quicker, and the advantage is that we can reuse this information.
Right.
Like if we take one combine, that combine goes to all the phase of treatment without exposing the patient to more radiation. If I'm doing quadrant dentistry, for instance, that I don't need to make variations in the bite, and the bite is going to be some consistent for the bite, the actual bite that the patient have, you have that file for chewing cycles and whatever, and you can do 1, 2, 3 restorations today, and in a month you're going to do more. You can use the same files and pull it up, because the other restorations, they were fabricated following the same parameters of movement that we have at the beginning, so we can jump into another quadrant or to another area, and the parameters will be the same. So I think we're successful totally.
Wow, this has really been interesting. Thank you so much for taking time and sharing the insight.
No, we need to thank him, because that's why we're here. I love that.
It's always a pleasure. Thank you. Thank you.
Thanks, guys.
Thank you so much.
We work actually from their input. You know, the discussions we have, that bring us forward.
Sure.
And that is when we start thinking.
That's
team effort.
That's what
it's
it is.
Always
totally.
a team effort.
Love it. Thank you, guys.
Thank you very much.
Taking a quick break. Back with more with SIROWORLD 2016 right after this.